Hello everyone, I am Balaji Rao. Welcome to BR Max class. We are in applications of derivative chapter. We are doing maxima minima concept. In this, what they are asking, when this function attains local maxima value, local minima value, and what is that local maxima minimum values if exists for this function. This problem as well as next problem will use first derivative test. Till now, whatever the problems we done in this exercise, all the problems we used second derivative test to identify maximum values, minimum values. For this problem, we'll use first derivative test. However, you can use second derivative test also for this problem. But if you use first derivative test, simplification can be done very easily. Let's see what is first derivative test. In first video of this maxima minima, I explained what is first derivative test. What is first derivative test? By using first derivative test, we can identify where the given function attains maximum value or minimum value, and what is the maximum value of that function and what is the minimum value of that function. These things we can calculate by using first derivative test. In this, now we are going to learn what is the working rule, how to use first derivative test to identify where the function attains minimum values, where the function attains maximum values. First point, when we use first derivative test to identify where the function is maximum or where the function is minimum, how to find what is its maximum value, what is its minimum value. To identify those things, we will use first derivative test. What is the working rule? First step, which function maximum values, minimum values you want to find, you take that function as f of x. Which function maximum values, minimum values you want to find, you take that function as f of x. Here, this is the function f of x. In this graph, this is the function f of x. Okay. After considering f of x, you just calculate f dash of x. You calculate f dash of x. You know how to calculate derivative of a function from differentiation. You calculate f dash of x. After calculating f dash of x, you observe we learned about critical points. At these points, the functions attains either maximum value or minimum value. You need to find these points. You know at these points, if we draw the tangents are parallel to x-axis. So to find these points, right, what I'll do, I'll equate f dash of x to 0. You equate f dash of x to 0 and solve this. If you solve this, then you will get x values. For example, I'll take x values are a, b, c, something like that you will get. You will get one or more than one value, right? So first thing is what? For which function maximum minimum values you want to find, you choose that function as f of x. After that, you differentiate that function and you will get f dash of x. After calculating f dash of x, you equate that to 0. You equate f dash of x to 0 and you solve this equation, then you will get x values. You observe here, at this point function attains maximum value. No? This is critical point. A value you got. At this point function attains minimum value. No? So you got b value. At this point function attains maximum value. No? Those values, critical values you will get. Okay. After calculating these critical values, what to do? This is important. Listen carefully. Here dy by dx means what? Dy by dx means derivative of the function f dash of x. You observe here, put x value which is slightly less than a. You see here, this is x value. Now you take slightly less than a. Slightly less than a. You put x value slightly less than a in dy by dx. For example, if you suppose this is 1, you take 0.9. You take 0.9, substitute that in dy by dx. Put x value which is slightly less than a in dy by dx and observe the sign of dy by dx. Sign of dy by dx means you observe that after substituting that x value which is slightly less than a, you observe that dy by dx is positive or negative. Just observe this sign, okay? And you keep that in your mind. Again, put x value which is slightly greater than a. Earlier what we did, we substituted x value which is slightly less than a in dy by dx. Now you take x value which is slightly greater than a and substitute in dy by dx. For example, this is 1. You suppose this is 1. You take 1.1, slightly greater than 1 and substitute in dy by dx and observe the sign of dy by dx. Just keep in mind dy by dx is positive or negative. At this A, in this particular graph, the function attains maximum value, right? At A, the function attains maximum value. Here, if I take a value which is slightly less than A, at that point, if I draw the tangent, you draw the tangent at the point where x value is slightly less than A. You can observe this makes acute angle. This line makes acute angle. This tangent makes acute angle with x-axis. We know that dy by dx is nothing but slope of the tangent. F dash of x is slope of the tangent. Here this tangent makes acute angle, na? So slope of the tangent, if theta is acute, that means theta lies in first quadrant. F dash of x will gives you slope of the tangent, that is tan theta. In first quadrant tan theta is positive, na? F dash of x is greater than 0. If the function attains maximum value at x equal to A, when we put x value slightly less than A, f dash of x is positive. At the same time, you draw the tangent at the point where x is slightly greater than A. You draw the tangent at this point. You can see that this is obtuse angle. See, greater than 90 degrees. I hope you can understand. This is obtuse angle. Obtuse angle means slope of the tangent is negative. Slope of the tangent is negative. Obtuse angle means in between 90 to 180 in second quadrant. In second quadrant, tan theta is what? Tan theta is negative. So what you identified, dy by dx changes the sign from positive to negative when it attains maximum value. I hope you are understanding this. You observe dy by dx changes its sign from positive to negative when the function attains maximum value. When you substitute x value which is slightly less than A, you observe the sign of dy by dx. Na? You suppose that dy by dx is positive. You suppose dy by dx is positive. And you are observing the sign. You suppose that when we substitute x value slightly greater than A, dy by dx is negative. What happened? Dy by dx changes from positive to negative. If dy by dx changes from positive to negative, we can say that function attains maximum value at x equal to A. You observe, I written the same thing. Dy by dx changes its sign from positive to negative. Then f of x attains maximum value at x equal to A. And what is the maximum value? Maximum value is f of A. The maximum value is f of A. In the same way, you observe at B in this graph, the function attains minimum value. Na? So you see here, if I draw the tangent, if I take x value which is slightly less than A, and if I draw the tangent at that point, the tangent makes obtuse angle. If the tangent makes obtuse angle means slope of the tangent, f dash of x is negative. F dash of x is negative. Okay, and you take x value which is slightly greater than B and draw the tangent at that point, you can observe that this makes acute angle. That means slope of the tangent is positive. So if dy by dx changes its sign from negative to positive, then the function attains minimum value. This is the example I explained at B. This may happen at A also, right? As you substituted x value slightly less than A in dy by dx, you are observing the sign of dy by dx as x value is slightly less than A as well as x value is slightly greater than A. If dy by dx changes its sign from negative to positive, here positive to negative, we already discussed when it is positive to negative. If dy by dx changes its sign from positive to negative, f of x attains maximum value at x equal to A and maximum value is f of A. If dy by dx changes its sign from negative to positive, then f of x attains minimum value at x equal to A. Not in this graph. In general, I am saying not in this graph. Okay. If dy by dx changes its sign from negative to positive, then function attains minimum value at x equal to A and the minimum value is f of A. If I do one problem, worked example related to first derivative test, then you will get more clarity. While doing exercise problems, I will do problem related to first derivative test. Here I checked function attains maximum value or minimum value at x equal to A. In the same way, I can check function attains maximum value or minimum value at the other critical points also. So this is the working rule for first derivative test. I hope you understand what is working rule of first derivative test, right? Okay, so we need to find local maxima, local minima of this function. To find those things, I'll use first derivative test. What I'll do in first derivative test, first I'll calculate this g dash of x. Okay, so you just differentiate the given function. How to differentiate this function? How it is? It looks like u by v. So to differentiate this, we'll use quotient rule, u by v formula. So you know what is a u by v formula, right? What is derivative of u by v? This is u, this is v. U by v formula is what? V into derivative of u dash, derivative of u minus u into v dash divided by v square. So v, what is v here? V is x square plus 2. Okay, v into u dash. U dash means derivative of 1. Derivative of 1 is what? Derivative of 1 is 0. V into derivative of u minus u, that means 1 into derivative of x square plus 2x. What is derivative of x square? Derivative of x square is 2x plus derivative of 2 is 0. So what is derivative of x square plus 2? Derivative of x square plus 2 is 2x. Okay, 2x, 1 into 2x divided by v square. V square means x square plus 2 whole square. If you simplify this, you observe this term will become 0. 1 into 2x is 2x. 0 minus 2x is what? That is minus 2x. So that equal to minus 2x divided by x square plus 2 whole square. Okay, now what I got? I got g dash of x. After calculating g dash of x, we'll equate this to 0. Like second derivative test only. Equate this to 0 and try to get the x values. Okay, so if g dash of x equal to 0, if g dash of x equal to 0, what is g dash of x? Minus 2x divided by x square plus 2 whole square equal to 0. Okay, if g dash of x equal to 0, find the x values which satisfies this equation. You see this expression is there. Na? You cross multiply, what you will get? 0 into this term is 0 only. So what you will get here? Here you will get that minus 2x equal to 0. We want x values, na? Divide with minus 2 on both sides. When we divide with minus 2 this side, this minus 2 will get cancelled. Right hand side part, 0 divided by minus 2 is 0 only. So what you will get? You will get that x equal to 0. So we got here x value is 0. Okay. So second derivative test means what we will do? After g dash of x, we will calculate g double dash of x. You can do this problem by using second derivative test also, but I felt that if we do this by using first derivative test, we will get the answer very easily. Okay, so you can use second derivative test also, but I am doing this problem by using first derivative test. Okay, so what is first derivative test? After calculating g dash of x and g dash of x is equated to 0, I got some x values here. Na? So what I will do here, I will calculate g dash of 0 minus. 0 minus means here, listen please. G dash of 0 minus. 0 minus means here x values are less than 0, very nearer to 0. So what I can take x values here, like minus 0.1, minus 0.2, like that I'll take. Okay, so if you take x value minus 0.1, you suppose substitute in g dash of x. X value you take in minus 0.1, substitute in this, what you will get? Minus 2 into x value is what? Minus 0.1 divided by this whole square is there. Na? Obviously this is positive only. Now you observe the numerator. What you are getting numerator? Minus 2 into minus 0.1. What is this? This is positive. Positive divided by positive is positive. So what I want here? I want g dash of 0 minus is positive or negative. So I got that g dash of 0 minus is positive. G dash of 0 minus is positive. Okay, now I'll calculate g dash of 0 plus. That means all x values are nearer to 0 but greater than 0. Suppose 0 is here like this, greater than 0, 0.1. You take x value 0.1. You take x value 0.1 and substitute in this. In place of x you write 0.1. What you will get? Minus 2 into, in place of x you write 0.1 divided by, denominator is clearly positive, right? Numerator is what? Minus 2 into 0.1. Minus 2 into 0.1 is negative. Negative divided by positive is what? Negative divided by positive is negative. G dash of 0 minus is positive. G dash of 0 plus is negative. So when G dash of 0 is changes from positive to negative, what I can say as G dash of 0 minus 0 plus changes from positive to negative, we can say that G of x attains local maximum at x equal to 0. And what is that local maximum value? Local maximum value. That local maximum value is G of 0. So in place of x you write 0 in this. G of 0 is what? 1 divided by 0 plus 2. That is 1 by 2. So G of 0 is 1 by 2. I hope you are understanding. In case if you felt this first derivative test is difficult, you can do the same this problem with second derivative test. I hope things are clear to you, right? So next problem you see, this is, we need to find, see here, we need to find local maxima, local minima of this function. Here they mention here x is greater than 0. Okay, this problem also I'll do by using first derivative test, so that you will get clear idea what is first derivative test, what is second derivative test, how to calculate maximum values, minimum values by using first derivative test, second derivative test, all those things you will get clear idea. Okay, now what I'll do, I'll calculate f dash of x. How to calculate f dash of x? See here, you just use quotient product rule, u v, okay, x into derivative of this one, root over 1 minus x. Derivative of this is what? 1 divided by 2 into root over 1 minus x into derivative of 1 minus x is minus 1. You know how to differentiate, chain rule differentiation. We are in applications of derivatives. I cannot explain all these things here, right? So what is the derivative of root x? 1 divided by 2 root x, that is 2 into 1 minus x into derivative of 1 minus x is minus 1, okay, into minus 1. So whatever I written here, what is this? This is derivative of root 1 minus x, okay. U into v dash plus v into v, that means this one, root 1 minus x into derivative of x. Derivative of x is what? Derivative of x is 1. U into v dash plus v into u dash. You do simplification of this, what you will get? You will get minus x divided by 2 into root over 1 minus x plus root over 1 minus x. Now you simplify this. Okay, let's simplify this. What is denominator? Denominator is 2 into root over 1 minus x. Okay, 2 into root over 1 minus x. In the numerator, what you will get? Minus x plus this into this. That is what? 2 into 1 minus x. Okay, simplify further. What you will get? Minus x plus 2 minus 2x. Okay, divided by 2 into root over 1 minus x, that equal to minus x minus 2x, that is minus 3x. So 2 minus 3x divided by 2 into root over 1 minus x. What is this? This is f dash of x, right? This is f dash of x. What is I said now we do this problem by first derivative test. I calculated f dash of x, I got like this. Why we are not using second derivative test? You may get a doubt here. Why we are not using second derivative test? In second derivative test, we need to calculate f double dash of x. See here, when we calculate f double dash of x, this is like u by v na, u by v formula, quotient rule. That second derivative is little difficult. So we can easily do this problem with the help of first derivative test. Then why to use second derivative test? I hope you are understanding. So this problem 100% we can do by using second derivative test. No doubt in that. We can do this problem by using first derivative test also. Okay. Now first I calculated f dash of x. Now I'll equate it to 0 and to get x values. Okay. Equate it to 0. If f dash of x equal to 0. Okay. If f dash of x equal to 0. What is f dash of x? 2 minus 3x divided by 2 into root over 1 minus x equal to 0. Now we need to find x values. Now take this to right hand side part, cross multiply. What you will get? You will get 2 minus 3x equal to 0. From this what you will get? X equal to 2 by 3. X equal to 2 by 3. We got only one x value, no negative x values here. So we got x value. 2 by 3 value is what? 2 by 3 value is 0.6, I think, right? 2 by 3 value 0.6, yes. So 2 by 3 value is 0.6. Now what to calculate? How to check local maxima, local minima by using first derivative test? What I'll calculate? I'll calculate f dash of 2 by 3 from left. That means x values are less than 2 by 3, very nearer to 2 by 3. I'll check this is greater than 0 or less than 0. Next, I'll calculate f double dash of 2 by 3 from right. It is less than 0 or greater than 0, like that I'll check. Okay. First, I'll check f dash of 2 by 3 from left. That means 2 by 3 is 0.6. Na? You take some x value which is left side of 0.6, very nearer to 0.6. I'll take 0.5. Okay, you take 0.5, substitute in this, what you will get? 2 minus 3 into 0.5 divided by 2 into root over 1 minus 0.5. I don't want this value, I just want it is positive or negative, that's it, right? You observe the numerator. What is this? 3 into 0.5 is 1.5, right? 2 minus 1.5 is positive, numerator is positive. Denominator you observe, 2 into root over 1 minus 0.5 is 0.5. This is also positive, numerator positive, denominator is positive. So what is this total expression? This total expression is positive. So I identified that f dash of 2 by 3 from left is positive. Now f dash of 2 by 3 from right, that means all x values are greater than 2 by 3, very nearer to 2 by 3. So 2 by 3 is 0.6 na? So you take 0.7, right? Take x equal to 0.7, substitute in f dash of x. 2 minus 3 into 0.7 divided by 2 into root over 1 minus 0.7. You observe numerator, 3 into 0.7 is 2.1, right? Divided by, denominator is clearly positive, right? Numerator you observe 2 minus 2.1 is what? 2 minus 2.1 is negative. Negative divided by positive is what? That is negative, right? So total this f dash of 2 by 3 from right is what? Is negative. So f dash of 2 by 3 at 2 by 3 changes from positive to negative. When f dash of 2 by 3 changes from positive to negative, what we say? We say that f of x attains local maximum. F of x attains local maximum at x equal to 2 by 3. And what is that local maximum value? Local maximum. What is that local maximum value? Local maximum value is f of 2 by 3. Right? So this is f of x. Na? In place of x, you write 2 by 3. What you will get? That equal to 2 by 3 into root over 1 minus 2 by 3, that equal to 2 by 3 into root over 3 minus 1, 3 minus 2, that is 1 by 3, that is 2 by 3 into 1 divided by root 3, that equal to 2 divided by 3 root 3. So this function is a local maximum at, this function is local maximum at 2 by 3, and the maximum value is 2 divided by 3 root 3. If you want, you can simplify this little bit. Numerator is what? Numerator is 2 into root 3 divided by, denominator is what? Root 3 into root 3 is 3 na? 3 3s are 9. Okay, so 2 root 3 divided by 9. However, you can stop here also. 2 divided by 3 root 3 you can write, which is same as 2 root 3 divided by 9. I hope you understand this class. Once again I am saying, whatever problems we did in this class, these two problems you can do with the help of second derivative test also. But you will find little difficulty while calculating f double dash of x. That's why I used first derivative test to do these two problems. If you like this video, please drop a like, share it with your friends. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye.